All right, we're going to be working with solving two-step inequalities today, and we're going to be following the same procedures as we did when we solved two-step equations. So those same where we have to add or subtract first, then multiply or divide to finish out. The big difference is going to be right here. If you multiply or divide by a negative number on both sides of the equation, so like that last step of solving the two-step inequality or the two-step equation where we multiply or divide, we are going to flip the inequality symbol. So if it is a less than, it becomes a greater than. If it's greater than, it becomes a less than. We then are going to graph our answer and then check our answers. So we have two examples here. We have 3x minus 11 is greater than or equal to negative 20, and then we have negative 2x plus 14 is greater than or equal to negative 18. The first one, they show us they identified where is the variable, which is x in this case, and then it talks about the coefficient. Remember, the coefficient is that number in front of the variable. In this case, it's a positive 3. In this case, it's a negative 2. So once again, when I solve an inequality, just like an equation, if I'm subtracting 11, I'm going to add 11 to both sides. Those cancel out, so they're all gone because they equal 0. Over here, I get negative 20 plus 11 is negative 9. And over here, I still have my 3x. In order to finish this, I'm going to divide both sides by 3 because I want to get 1x here. Remember, there's a 1 here. We just don't write it. And then I have negative 9 divided by 3, which gives me a negative 3. So I have x is greater than or equal to negative 3. I fill in my dot, and I'm graphing everything over here as a possible answer that would make this a true statement. So the way I check that, I can pick a number from over here. So anything equal to or less or greater than, rather, negative 3. So say I pick negative 2. So I'm going to go back up here, and I'm going to plug in where the x is. Where the x is, I'm going to plug in a negative 2. And so then I get negative 6 minus 11 is greater than or equal to negative 20. And when I finish that out, I'm going to have to pull it over here, but I'm going to get negative 17 is greater than or equal to negative 20. And you're like, no, that's not true, but it really, really is, because what happens is this is closer to 0. That negative 17 is closer to 0 than negative 20, which does make it greater than. So then on our second one over here, I've got negative 2x plus 14 is greater than or equal to negative 18. And I notice that my coefficient this time is negative. So I'm going to subtract the 14 from both sides because I was adding it. This cancels out because equals 0. Over here I get negative 32. Negative 18 plus negative 14, negative 32. Negative 2 times x, so I'm going to divide by negative 2 because negative 2 divided by negative 2 gives me that positive 1 that I'm looking for, okay? Whatever I do to one side, I have to do the other side. Negative 32 divided by negative 2 is a positive 16. Now, if I had not flipped my sign and I had shaded this way, if I take 17 and I plug it in to my original inequality, I get negative 34 plus 14, which gives me negative 20. And, uh-oh, that is not correct, is it? That is not true. So that is why in that last step, if I divide or multiply by a negative number, I have to take this sign right here. And when I finish out, I'm going to flip it to go the other way. So why is it important to identify the coefficient of x? Well, if I look at the coefficient, if I notice that it's negative, right away I'm like, end of the problem. I have to remember to flip that sign. So if the coefficient is negative, I need to flip the inequality symbol at the end. And it kind of says that right there as well, right? Now it comes down here and says, wait a minute, in that first example, though, we had some negatives there. We had a negative answer. So why don't we flip it here? Well, it doesn't matter if the answer is negative. Only the coefficient can flip the inequality sign. And we should really say only a negative coefficient can flip the inequality sign. So down here at the bottom we have two practice problems. If I can get my fingers under there. And the first one that I have here is negative 3x plus 31 is less than 25. So I find that variable and that coefficient is negative. So I know at the end I need to flip. I'm going to solve this just like I solve an equation. So I subtract 31 from both sides. My last move is I have to divide both sides by negative 3. When I do that, I don't just bring that down, I have to flip it. Open circle, and this time it's greater than, so it's going that way. This one over here also presents a special kind of situation. We typically want the symbol and the number by itself to be on this side and the variable to be on the left. When I move that over, we've done this with equations. In the equation, I just put an equal sign, no big deal. Right now, this 43 is bigger than that. If I don't turn my symbol or flip it, suddenly the 43 is smaller. I don't want that. That's not the statement I'm making. I want my 43 to be greater. So when I move it over, I have to flip the sign. And then I can just cross that out because I don't need it. When I come back in here, there is my variable, and that is a positive 5, so I'm not going to flip the symbol when I get done. I'm going to subtract 8 from both sides. Divide by a positive 5, and y is less than or equal to 7. It means I'm going to shade in that direction. On the back, and please feel free to pause this at any time if you need some more time to write something down, or rewind it if you need to go back over something. On the back, I have that similar situation to that last problem I did where I need to move this over to the other side. So I'm going to move the 30, and then I'm going to flip the sign because my 30 was less than that, and I want to keep that the same. I'm going to subtract 33 from both sides. And I notice that underneath my variable, I've got a negative number down there. It means we're going to have to flip it at the end. A lot of people are having trouble with this. I am dividing the x, so x divided by negative 3. To undo that, I have to multiply. I'm going to multiply by that same number. These cancel each other out, so I have an x. When I come down, I'm flipping. Negative 3 times negative 3 is positive 9. Close dot, it's less than, so it's going in that direction. Over here, my variable's on the left, so I don't need to move anything. My variable, I notice, is being divided by a positive number, so no flipping at the end, no flip of my inequality. We've got an open circle, and it's going this way again. Down at the bottom here, you're going to want to pause, try these out, and then check your answers. So there are those answers. You're going to want to pause and check those out. And then when you unpause, you'll be able to see that last one here. Our word problem here, magician's assistant makes $10.60 an hour if he has already saved $53.70. How many more hours does he need to work to save at least $165? So in other words, the amount saved, so money saved, they want it to be at least, so they want it to be greater than or equal to $165. So we know that he has, or she has, $53.70. And then every hour that they work, they get $10.60 more. But we don't know how many more hours does he need to work. So that is going to be our variable. Now that looks like something we can solve. So we're going to subtract the $53.70. I mean, that is what you would do in real life, correct? You would subtract how much you have from how much you need to figure out how much more you need to get to your goal there. Oh, it's Friday, friends. Little brain dead there. 10 minus 7 is 3. 4 minus 3 is 1. 1. There we go. We're going to double check that because it is Friday afternoon. Mrs. Williams' brain might not be working on full alert. Oh, we got it right finally. Yay, there it is. So last step is we're going to divide by $10.60, and we're dividing by a positive number, so we don't need to flip that symbol. And when I do that division problem, I get 10.5, which means the magician needs to work 10.5 hours in order to save $165. I hope this was helpful. Remember, you can always pause, go back, rewind, redo stuff. Email me if you have any questions. After you finish this up, digits 9.3 should be pretty easy for you if you want to give that a try.